So here's a problem where we need to calculate the value of the free energy change, delta G, at 25 degrees Celsius, knowing the delta H of the products and reactants and the delta S of the products and reactants. So the two things that we need first are our delta H of reaction and our delta S of reaction. So let's take a look at those things. So our delta H of reaction is going to be equal to 2 times our delta H of our PCl3, it's products minus reactants, minus our delta H of our P2, that's added to 3 times the delta H of our Cl2. So we plug in the numbers for that, and we get a delta H of reaction that's equal to 2 times negative 287 kilojoules per mole minus 144.0 kilojoules per mole plus 3 times 0. Since Cl2 is in its elemental state, its enthalpy is 0. And so here we reach a delta H of reaction equaling negative 718 kilojoules per mole. So a very exothermic reaction there. The other thing we need to do is to calculate the delta S of reaction. So let me change colors here. So our delta S of reaction is going to be the same equation as the delta H of reaction, except rather than using delta H's, we're going to be using delta S's. So we have 2 times our delta S for PCl3, so that's 311.78 joules per Kelvin mole, minus, and we're going to have 218.1 joules per Kelvin mole for our P2, plus 3 times the delta S for Cl2, and that is 222.96 joules per Kelvin mole. And so when we add that all up, we get a delta S of reaction that is equal to a negative 263.42. Now, in order to get delta G, we need to find an equation for delta G. We know that delta G is equal to delta H minus T delta S. We're given a temperature here of 25 degrees Celsius, which of course is equal to 298 Kelvin. The other thing I need to be aware of is my units for entropy and enthalpy. I forgot to write my units out for my entropy. That's going to finish out at joules per Kelvin mole. And notice that my energy unit in my enthalpy is a kilojoule, and the energy unit in my entropy is a joule. So we want to make sure that those are going to be the same. And so we just need to take our delta H and multiply that by 1,000 joules per kilojoule, and now we have a negative 718,000 joules per mole for my enthalpy. And this will work out much better for our free energy calculation. So let's do our free energy calculation now. And so we have delta G is going to be equal, actually let me change that. We get delta G of reaction. It's going to be equal to my delta H of reaction, which is negative 718,000 joules per mole, minus my temperature, which is 298 Kelvin, times my delta S, which is negative 263.42 joules per Kelvin mole. and all of our units start canceling out very nicely. Our kelvins cancel out there, and we end up with only joules per mole. And our final equation, we get delta G reaction is equal to negative 639,500 joules per mole, which is equal to negative 639.5 kilojoules per mole.